Hello everyone, myself Dr. Bhagwanti Bishnoi, Assistant Professor in Department of Applied Sciences, Kite Group of Institution. Today I will demonstrate a practical on variation of magnetic field. In this practical, the main objective of this practical, that what we need to determine in this practical is the radius of a circular coil. That is, we need to plot a graph showing the variation of magnetic field with distance along the axis of a circular coil carrying current, and from that we need to estimate the radius of a coil. For that we require some apparatus, and that we require is tangent galvanometer of Stewart and G type. Tangent galvanometer basically works on the phenomena of tangent law. Then we require a battery, we require a rheostat for varying the resistance, and a commutator key whose main function is to reverse the current, and magnetic compass box, which is important, plugging keys, and next is our connecting wires. So the formula used in this experiment is the magnitude of the field B along with the axis of coil by the formula is given by B equal to mu, N is the number of turns on the coil, I is the current used, R is the radius of the coil, 2 bracket R square plus X square raised to the power 3 by 2. Where x is the distance of the coil from the center. But in order to find out the radius of a coil, we are not going to use this formula. We will prefer an alternative method to find out the radius of a coil, and that method is by plotting a graph versus distance versus a tan theta. So from that graph we will calculate the radius of a coil, which I will show it right now. Thank you. In this experiment, we will find the radius of a coil by using a tangent galvanometer. So in this experiment, we require a magnetic compass box, a commutator key, which is a two-way key, a rheostat, a variable for varying the resistance, and a battery. So first of all, in order to find out the radius of this coil, we will adjust this apparatus in a magnetic meridian. Magnetic meridian means that we need to adjust this experiment according to the earth horizontal axis. We know that as soon as we will put on the current, a circular coil carrying a current give rise to a magnetic field. So there is also a magnetic field by the earth. So we will eliminate the magnetic field by the earth. So for that purpose we will adjust this experiment in a magnetic meridian. So for the magnetic meridian, I will move this bench in such a way so that in the magnetic compass box both the needles exactly coincides with the 0, 0 of this magnetic compass box. I will move the table till the end where both the needles exactly matches with the 0, 0 on both the sides. As soon as it matches on both the sides with 0, 0, we have to parallelly see that we have to adjust this magnetic compass box with this optical bench exactly at the mark given over here matches with the 0. Then we will move this optical bench. As soon as both the pointers crosses on the 0, 0 mark, we will see that there is a black color pointer in this magnetic compass box which has a red dot over here. The red dot facing whichever side gives me the north direction, and this is my east and this is my west. So now what I will do, as soon this apparatus is already adjusted in the magnetic meridian, now I will put on the current over here. As soon as I will put on the current over here, a magnetic field is generated around this coil. Because of this magnetic field, my magnetic compass box will show the deflection. Now it is showing a deflection. One of the pointer is showing in the range of 74 degree and another pointer is matches with the 74 degree. So once we have to see that it should come in the range of 70 to 80 degree. If both the needles exceeds 80 degree, then with the help of rheostat we have to adjust in the range below 80 degree. So in this case, already in this experiment, my readings are coming below the range of 80 degree, so I don't have to move the rheostat over here. Now what I will do it, as this is my east part, this is my west part, I will move my magnetic compass box to check the readings. That is, first of all I will place it at 2 centimeter and I will take the readings. So for the reading I don't have to touch any other part of this experiment, that is, we don't have to change any current value in this battery, we don't have to move the rheostat, just we have to use this commutator key. Commutator key has a function which reverses the direction of a current. For example, right now I have placed both the ends in the opposite way. So in this case, if my current is moving in a clockwise direction, I will note down the readings of both the pointers as theta 1 and theta 2. For example, my theta 1 is coming at something 76 degree and theta 2 is coming at 75 degree. So this I will note the reading as theta 1 and theta 2. Now I will move both the keys and put the keys in other two opposite ends. By doing this, I will press the keys tightly so that the connections remains intact. Now what will happen, by placing both the keys in opposite direction or opposite way, now the direction of my current is reversed. Because the direction of current is reversed, even though it will generate a magnetic field, now in this case my pointer will show the values of theta, and in this case now I am getting the value of theta, something is 69 degree and this is 71 degree. So my theta 1 and theta 2 were 74 and 75 degree, theta 3 and theta 4 I got by reversing the direction of current using the commutator key, and I am getting the value of 69 and 71. So basically it is not ideal that we should get all the thetas as same reading. We are doing a practical, so there are the chances we get the same readings of all the thetas, that is theta 1, theta 2, theta 3 and theta 4, and there may be a case where we can get all the values as different, because in physics the practicals are performed and we are not working on an ideal condition. We are learning something over here, so the values even can moderate over here. So in this way we will perform this experiment. Now I have taken the reading for 2, so I will move my compass box towards the 4, then 6, then 8, and I will move towards the 16. So as soon as I will move this compass box ahead from this center part, the effect of magnetic field on this magnetic compass box goes on reducing. That is, the deflection value of thetas which we are getting, it will go on reducing. That means it can go up to 20 or 25 degree. So I will take nearly 7 to 8 readings in the east direction. Then I will bring the magnetic compass box back to the central position, that is 0, and now I will do the same process in the left hand side which I have done in the right hand side. So I will take the reading still 16 on the right hand side, that is the east side. I will take 16 readings on my west side, and in this way I will complete this experimental part. Thank you. So here for this experiment we will draw an observation table. In the observation table we will have 2 columns. One is deflection on east side and second is deflection on west side. So here I will divide the parts over here, that is direction of commutator key or I can write it instead of direction of an commutator key, we can write it as clockwise direction, and this is my anti-clockwise direction. So in the clockwise direction, I will note down the reading as theta 1 and theta 2, and in anti-clockwise I will note down the reading as theta 3 and theta 4, and after that I will have another column, that is mean theta and tan theta. So here this column is my distance, and distance I will start over here from, right now I will take 2 centimeter, then I will take 4 centimeter, then 6 centimeter, 8 centimeter, 10 centimeter, 12 centimeter, 14 centimeter and 16 centimeter. So in the first case, if I get the value of theta 1 as 70 something, I am getting the value of 71 degree, and my theta 2 I am getting something 74 degree. Similarly, for the anti-clockwise direction, I am getting the value of theta 3 as 69 degree, and my theta 4 I am getting as 72 degree. So if I will calculate mean theta, that is I will add all the thetas and divide it by 4, so approximately I will get some value of 73 degree, and then I will find it out tan theta of 73 degree, it will come out something 3.2 approximately. I am writing, I have not calculated, but somewhere near in the range of 3.2 we will get the value. So as soon as I will go on increasing the distance, the value of theta 1, theta 2, theta 3 and theta 4 will go on reducing. That is, I am getting 71 over here, maybe I can get something 69, then something 50s, and in this way the value till 16 centimeter it will go on reducing. Same process which I have done it on east side, same process will be done on the western side. That is, I will calculate theta 1, theta 2, theta 3, theta 4, then mean theta, and finally I will get right down here is tan theta. There may be a condition that I can get the same values which I have got in the east side, I can get the same values, or my values can differ also. Because we are doing a practical, nothing ideal conditions, we are not working on it. So the readings can vary. So right now I can write it something on an approximation, that is something I am getting 70 and 72 and 65 and something 69. So my mean theta will be in the range of something 69 or 70, and approximately my theta, tan theta I will get in the range of 3 or 2. So in this way we will perform the experiment. I will write down all the readings over here, fill all the columns over here. Then, as I have stated, we will use an alternate method to find out the radius of a coil. So that alternate method is nothing but we will draw a graph. Draw a graph, that is, this is 0 and my x-axis will be as distance from the center, and my y-axis will be nothing but it will be tan theta. So what I will do is 0, this is 2, this is 4, this is 6, this is 8, this is 10, 12, and same way over here 2, 4, 6, 8, 10 and 12. So we will write down the readings over here, and further 2, 4, 6, 8, whatever I am getting the value of tan theta, that tan theta I will write it over here. So if I see for 2 centimeter, this is a maximum value 3.2. After that the tan theta will go on reducing. So maximum I can go for 3.2. So I can divide this part as 0.5. This is 1. This is 1.5. This is 2. This is 2.5 and this is 3. So I will accordingly I will take the readings and I will draw the points over here. That is something in this pattern I will get the points. So if I will draw a graph with a free hand, not joining the points but with a free hand, if I will draw a graph, I will get the pattern something of this sort of type. And never join point to point. While drawing a graph, never join point to point, always draw a graph with a free hand. So now what I am going to do here, to find out the radius of a coil, what we will do, we will choose the point of inflection. As you people know that what is the point of inflection? It is a point from where the continuous curve changes its form, or I can say the curve from the curve which changes its form, that particular point we will call it as a point of inflection. So in this curve I can say something at this point and I can write it as this point. So I will drop a perpendicular. So what I will get the value, this is from 0 to this, that is something 5. This is from 0 to this, that is not 5, that is something 4.8. So here 5 plus something 4.6, this comes out to be something 9.6. So this is known as 9.6 is nothing but it is the radius of my coil. So this method we are preferring to find out the radius of a coil rather than the formula used. So you have to choose a point of inflection whenever you take this reading. Thank you.